Hi and welcome. We're going to be talking all about statistics today and ways in which data arises. So let's begin, and we're going to start talking immediately about data that arise based on a possible discrimination case based on data at a bank. At this bank, there were 32 males and 61 female employees. And our goal here is, do men have a higher starting salary than women? The goal of statistics and the role of statistics here is if the salary difference is due to random chance, or if there is a causal relationship between salary and biological sex, and we'll use data to assess this claim. Our goal is to use inferential statistics to evaluate this claim. Okay. Here, when we have a subset of the data or the population, we have a statistic. That could be your sample average. It could be other things like your standard deviation or your maximum value. Those are all based on your data and hence a statistic. When we have the entire population, all the data, that's called our population parameter. The goal of inferential statistics is to use a sample to make conclusions about the entire population. In this data set, we have all these variables. We have the annual salary at time of hire, we have the sex of the employee, the seniority, the age, the education in years, and the experience. A natural question that can arise here is, what kind of data analysis can we use? This depends in part on the type of data we have. So we can have quantitative data, and there are two types of quantitative data. There's a continuous variable, one that takes on every value between 2 points or has an interval of outcome. So in this data set, age is a continuous random variable. We age continuously. A discrete random variable is also numerical, so it's quantitative, but it has a finite number of outcomes. So in the banking data set, education measured in years is our discrete random variable. Now, our final type of variable is qualitative. And qualitative is non-numerical data and is typically an attribute. Okay. It could also be a characteristic. In our banking data set, the variable sex is categorical. There are a lot of studies out there, and here's the headline of one that says, eating chocolate is good for your heart. And this is somewhat skeptical, because if we just keep eating chocolate, does that mean that that's better for our heart? How solid are the conclusions of this result? Well, in order to understand how trustworthy the results of a study is, it's really important to identify both the components of the study and, most importantly, the type of study. So here we want to identify what population or individuals we're dealing with. And this study took place in Europe, so it's European adults. The treatment here, which is also called the input variable or explanatory variable, is chocolate consumption. How much chocolate did people consume and how often? The outcome or response variable is heart disease. And our goal is to understand if the input affects the output. So does X affect Y? If X is the treatment and Y is the response variable, does changing chocolate consumption affect your Y variable in this case? Well, this is trying to understand cause and effect. And that's a very hard question to answer in statistics. Here we have Joanne Mason, who's the chief preventive medicine at Brigham and Women's Hospital in Boston, who said the study doesn't prove a cause and effect relationship between chocolate and the reduced risk of heart disease and stroke. Well, how did they make this decision and this conclusion? Well, here in this instance, what we have is an association, okay? And that's all that we can claim from this study. And that's because of the type of experiment or the way in which this data was collected. So if we really want to answer, can we trust the results? It rests in large part on the type of study. And there are two types of studies that we're going to discuss here. One is an observational study. That measures the value of the responses of the variable without influencing the input variables. Okay, so basically, the researchers only observe the data and they do not affect or prescribe how much chocolate individuals can eat in consideration of the last study. However, if a researcher randomly assigns the individuals in a study to groups, the explanatory or input variables, and records the values of the response for each individual, then we have a study that is a designed experiment. Okay? And what's key here for a designed experiment is to randomly assign individuals to specific input variables. Okay. So let's consider this study in which a certain kind of meat processing began once the pH in postmortem muscle of steer carcasses has decreased sufficiently. To estimate the time point at which pH has dropped sufficiently, 10 steer carcasses were assigned to be measured for pH at 1 of 5 times after slaughter. So let's think through this study and think through what variables we have. Our first question is, what's the response variable? Well, we want to know the pH in the carcass. That's our response variable. What's the input variable? The time after slaughter at which it's measured. Okay. And the type of study here is a randomized designed experiment because they assigned, and it should be stressed, although it wasn't stressed enough in the previous slide, that it's the steer were randomly assigned to various different times to be measured. Okay, so based on this type of study, it being a designed experiment, it's unlikely that there could be any confounding or lurking variables. And we'll discuss what confounding or lurking variables are on the next slide because of the randomization in the designed experiment. So any differences, unaccounted for variables, are due to random chance. Okay. And because of this, conclusions from this study are deemed to be very reliable due to the nature and type of study. And so based on what we find, once we apply some statistical methods, we may claim causation because of the designed experiment. Okay. So another important consideration in thinking about if we can trust the results is if there's any type of confounding. And this is an issue with observational studies. Observational studies do not allow you to claim causation, only association. And one argument for that is confounded by other variables or other input variables that could explain a difference. So confounding occurs when two variables that affect the output are not separated for or accounted for, and any conclusions from the study may be due to the other variable. So there are two types of confounding here. There's a confounding variable, which is a variable in the study that can't be distinguished from another variable. There's a lurking variable, which is an input variable that was not considered or recorded in the study, but that does affect the response variable in the study. So this is one reason why observational studies only allow you to claim association. And let me give you an example of a study in which there was a lurking variable. So in this study, researchers were trying to understand standardized test scores in a certain grade. Okay. And what they found was that taller children tended to perform better on the standardized exams than shorter children. Based on these conclusions, you could say that taller children perform better or are smarter. But if you looked into the data more accurately, you would discover that there's a lurking variable. The children who were taller tended to be older and hence more cognitively developed. So the performance of these children was due to the cognitive development in age, not the height difference. Okay, here's an example, and take a minute to read this over, made by Dr. Fauci and in discussion with Representative Elaine Kutemeyer concerning the treatment of hydrochloroquine. So, in the pharmaceutical industry, a designed experiment is the gold standard, and there are many documents that state this in the different stages of drug development. So, because this study was not a randomized designed experiment, the main issue that Dr. Fauci has is that we can't trust the results because of the type of study. The study is also confounded by the use of corticosteroids. Okay, so this is an interesting exchange in which we want to know what is an effective treatment. Okay, and it doesn't mean that one is or is not a valid treatment. It just means that this study did not meet the standard put forth by, I believe it's the FDA here, and they have documents stating that we have to have a designed experiment to be considered. Okay. Here's another study, and the researchers in this study wanted to know if there are anatomical differences, specifically brain size differences between schizophrenic individuals and non-schizophrenic individuals. So, are there physiological indicators that indicate schizophrenia. And this could be used by doctors as a detection or a possible clue that someone could be schizophrenic or not. So in this 1990 article, researchers reported the use of a study that controlled for genetic and socioeconomic differences by examining 15 pairs of monozygotic twins where one twin was schizophrenic and the other was not. The researchers used MRI imaging to measure the volumes of several regions in the brain. Here, our response variable, what we're trying to measure, is brain volume. The input that we're trying to consider here is schizophrenia. Do individuals with schizophrenia have smaller brains or potentially larger brain volumes than non-schizophrenic individuals? Is this a randomized designed experiment, and are there confounding and lurking variables? So this is not a randomized designed experiment here because we can't assign people to inputs. We can't assign someone to be schizophrenic or not schizophrenic. It's just not possible. So a designed experiment doesn't exist. Are there confounding or lurking variables? This is unlikely because the data is what is called a match-paired experiment. And a match-paired experiment is an experimental design where participants are matched in pairs based on shared characteristics before they're assigned to groups. So in this way, confounding variables are mitigated, confounding or lurking variables. In this instance, we're matching based on twins. So they're in the same family. Socioeconomic and biological differences are believed to be accounted for in this instance. And while this is not technically a designed experiment, we deem the conclusions very reliable because we don't believe that there are other confounding variables. Okay. Okay. So here's another instance of random sample and presidential elections. So in this instance of collecting data, U.S. polling met with significant success until the 1948 election. So meaning they had made good predictions for who would be the next president. They predicted a victory by New York State Republican Thomas Dewey over Democratic President Harry Truman. Obviously, we've never heard of Dewey, at least in the president name. So what went wrong? So here's how they collected the data. The polling methodology routine used was quota samples, which gave the interviewers the ability to choose respondents more or less on their own, with quotas for how many individuals they sampled. The accuracies of these polls had been unchallenged by the media and the public. However, some statisticians and some academics noted there could be some error. So what went wrong here? What went wrong was the way in which the data was collected. Giving individuals the freedom to choose how they collect the data was an issue. So to represent a population, we need a random sample of the population. And in 1948, these individuals chose to make telephone calls, not all of them, but a lot of them. And in 1948, individuals who owned telephones tended to be tended to be higher income, and also that affected who they were likely to vote for. Okay. So this is what's called a convenience sample. It's a biased sample of the population. So if we want to accurately represent a population with our data, the population in the sample, we need to give every individual in the population the same odds of being included in the study. And this occurs when we have a simple random sample or just a random sample. So a random sample is the process using chance to select individuals from a population to be included in the data. Okay. Thank you very much.